Testing claims about a proportion. So we are going to do two different methods. So the first one is called normal approximation to binomial. Distribution. The second one, there's other methods using technology only. The normal approximation method is we are going to use a normal distribution as an approximation to the binomial. Our key elements is that we are going to test a claim about a population proportion. So we need to do some notation. So N is always your sample size. P is going to be your population proportion. This is the value used in your hypothesis, H0, the null hypothesis. P hat, this is going to be your sample proportion. And you can find that by taking how many had success. So X would be like how many successes you had over your total sample size. So binomial, remember you have two choices. You have success and failure. That's always binomial. So make sure to remember that. You have two options, success and failure. The requirements for this normal to binomial is that you have a simple random sample, and then binomial distribution requirements are satisfied. Fixed number of trials. Trials are all independent. You have success and failure, and then the probability of success remains the same in all trials. Conditions N times Q being greater than 5 and N times P being greater than 5. We've seen these before when we first introduced binomial distributions. So these are the conditions that you have to have. Mu, which is our mean, is always found by doing N times P. And then our standard deviation is found by doing square root of N times P times Q. And again, P is found from your H0, population proportion. Z is the test statistic that we are going to look at. We are going to find that by doing P hat minus P divide by square root of P times Q over N. Once you find your z, you can find the p-value, because remember we're going to compare the p-value to our significance level. We can look at the p-value from the table for z-scores, A2. Remember, this is with your z-score. The p-value, it's the same as like area or probability. And on the table, it always represents area to the left. So pay attention to that. We can also use technology, though. You can go to Stat, Test, one proportion z-test. So you can do it either way, using the table, looking for that z-score, coming up with your probability, the p-value, or using the technology. So I just want to show you what the technology is going to ask for whenever we put that in. So you'll go to Stat, over to Test, so one means one population, one proportion z-test. It's number 5. It asks for your p-naught. It's what we're looking at, the hypothesis. That's your null hypothesis. That's what we're looking for. X is how many successes, whatever success is considered. And N is your sample size. And then on 8.1, we talked about, is it a two-tail, left tail, and right tail? So this comes, your proportion, this comes from your alternative hypothesis. Because your null is what it equals. Your alternative is the inequality. Okay, so let's think back to that drone example. Are you comfortable with the drone delivery from 8.1? So our sample size was 1,008. Let me pull it on real quick. Oh, no, it's 1,009. Oops, fix that. 1,009. So this was from 8.1. 54% responded no. 54% were uncomfortable with drone delivery. The test claim is majority of consumers are uncomfortable with drone delivery. So we need to check requirements before we think of this as a binomial distribution. So sample observations are simple random. They collected it from doing a poll. This is in the beginning of chapter 8 in the book. So this is true. Fixed number of trials. There were 1,009. Trials are independent. If you're just asking a person, are you comfortable or not? Yes or no. They're independent. 2 trials. Yes. We have either comfortable or uncomfortable. So success is considered uncomfortable. Uncomfortable. And then failure is comfortable. Because that's what we're testing. We're testing how many are uncomfortable. So that's considered success. The probability of success remains the same. Success is uncomfortable. It says majority, so remember how we talked about 0.5 being the number. of majority. If it's greater than 0.5, then it's considered majority. So probability of success remains the same, half. N times Q is greater than 5. So N is 1,000 times Q and N times P. So Q on this and P on this are both 0.5. And that came from the test claim. Majority means half. So if I do times 0.5, of course, that's more than 5. So this is, that one's okay. So let's go ahead and write our null hypothesis. This one is the equal. So whenever you do your null, you write whatever it equals. So 0.5. And our alternative hypothesis is what we're testing. Majority means P is greater than 0.5. Oh, P here is 0.5. Z is found by doing P hat minus P over square root of PQ over N. So I'm going to do it over here because I did not give myself enough room here. So P hat, that's what, so I need to find that too. P hat is found by doing X over N. How many successes were there? In our original, it was 545, I think. Let me see. Yeah, 545. We write that over there. So we're going to take this and subtract from P. So what I was saying in 8.1 was sometimes it needs you to do the full number because of rounding. Whenever I do that, it's like 0.540138. So if I just go ahead and put that in my calculator, minus 0.5, and then I'm going to divide by the square root of P times Q, so it's 0.5 times 0.5 over N. So that's 2.55. I'll just go to 2 decimal places because that's how it works with the z-score because of the table. It just requires 2 decimal places. So we're going to look at the table first, and then we'll look at technology. So we have a z of 2.55. We need to look at the p-value and compare it to our significance level. So if we look here, 2.55, so we're on the positive side, 2.55, 0.9946. But this is the area to the left. But we want the area to the right because this is, we're talking about greater than, right? Greater than 0.5. So we need to find the area to the right. So that's why we do the 1 minus 0.9946. .0054. And when we want to either accept or fail to accept the hypothesis, we need to compare the p-value to the significance level. So is it less than, greater than, or what? So I'm going to put this at 0.0054 compared to our significance level of 0.05. Yep. So to determine our result, look back on 8.1, page 2. And whenever you compare, so make a decision, it says p-value is less than significance level, we're going to reject the null. All right, let's look at the next problem. Go ahead and read it, and then we are going to fill in information from the, oh, we didn't do technology on this. Let's go ahead and do technology. Sorry, y'all. Go to stat, test, one prop z test. P naught is from our hypothesis, null hypothesis, so 0.5. N is 545, or X, sorry. 1009 is for N, and we want it to be greater than. Calculate. Okay, so it gives us our Z, which is the same Z that we got, 2.549, blah, blah. So 2.55. P is our P value, 0.0053. Really close, right? And then it gives us our P hat and our N. So it doesn't tell you what to do with it. It just gives you the information. And then you compare the P value to significance and then decide whether to reject or fail to reject. So what example 2 gives us is the output from our calculator. So go ahead and read the problem, and then you're going to answer the questions. I'm going to give you a minute to read the problem, and then we'll go through it together. We're going to kind of go out of order. Let's start with, what is the null hypothesis? What is it saying? What is the claim number? Null and our alternative. Let's go ahead and identify those. Our null says equal, so P equals something. And our alternative say P is either less than, greater than, not equal to. So claim that less than 9% experience headaches. So P would be the 9%, so 0.09. That's our claim. And then we do the alternative. It has to be less than 0.09. And so look at how it's represented in our output. P is less than 0.09. So this is our H naught, or H alternative. And then, so what would this be considered? Two tail, left tail, or right tail? Do what? Mm-hmm. Yep. So look back at page 4 of 8.1. I'll show you mine. This is how you determine it. If it's not equal to, it's a two tail. If it's greater than, no, less than is left tail, greater than is right tail. So this is left tail. Test statistic. So from our output, our test statistic is the z-score. negative 1.98. And so that also tells you if it's left-tailed. If it's a negative, if your z is negative, it's left. If it's positive, it's right. Our p-value is just p. To decide whether to reject or fail to reject, we compare our p-value to our significance level. Tells us our significance level right here, 0.01. And our p-value is greater than the significance level. So let's look at what that means. Greater than means fail to reject. So when you fail to reject, there's not enough evidence to show that the claim is true. So fail to reject, there is not, or insufficient is another word, not sufficient evidence to support the claim that less than 9% of treated subjects experience headaches. Exact methods for testing claims, not estimated using the normal distribution. Get exact results by using binomial probability distribution itself, and doesn't require n times q is greater than 5 and n times p is greater than 5. So the steps are identify the sample size you're in, number of successes x, and then your claim population proportion used in your H-naught. And then decide whether it's left-tailed, two-tailed, or right-tailed. So whenever you do left-tail, it has the less than or equal to. So it's p, x, or fewer. Right-tail, we have the greater than or equal to, p, x, or more. And then two-tail has a not equal to. You're looking at the probability that x is exactly. So go ahead and read the next example. So this example is the normal distribution as approximate to the binomial. This is not the exact method, even though we just talked about the exact method. So we look at the claim. Claim that the return rate is less than 20%. So our null says that the return rate is equal to 20%. So P equals 0.2. The alternative is what the claim says, less than 20%. So the less than means it's a left tail. Look at the table or use technology. Let's go ahead and use technology. Test one prop C-test. So the value that we're looking at is for 20%. X is how many were returned, 1350. N is how many were total sent out. We're looking at a less than. So P naught is 0.2, X is the 1350, N is the 6991, and then we want less than P naught. So calculate. And it gives us the Z, which is a negative 1.44. And then your p-value is 0.07. And you want to compare that to your significance. This is our significance. This is our p-value. What symbol? Oh, no, this is the wrong one. It should have been this. Sorry. I wrote the wrong thing there. But still, what's the symbol that goes between them? Greater than. So a greater than, look back at your notes. What does greater than mean? Yep, so fail to reject H naught. Okay, so because the p-value is what? Greater than? Greater than the significance level. We are going to fail to reject the null hypothesis. So if you fail to reject, what does that mean about our information? Let's see. Fail to reject, there is not sufficient evidence to support the claim. Did we fail to reject the last one? Yeah. So there is not sufficient, or there's insufficient evidence to support the claim that the return rate is less than 20%. Okay, let's go ahead and look at this one. Last example. I want y'all to read it. This is the first one of this kind that we've done. So let's first identify the hypothesis. So our null and our alt. So our null is, says we are going to test the claim that the proportion of subjects who respond in favor is 0.5. So P equals 0.5. So our alternative, it's whenever it's equal. So this is a two-tailed test. So we write does not equal 0.5. So we need to identify what n equals x. We know what p is. And we know that we're going to use the not equal to. So whenever I worked this problem, I kind of got confused because of the whole excluding the 121 subjects. So I guess I should have circled that and then marked out the 121 in there. So n is going to be all except for the 121. So n will be found by doing the 487 that were in favor and the 398 who opposed. 880? 885, okay. So X, which one are we looking at? In favor, the 487, yeah. So let's use our technology to find our test statistic p-value to make our conclusion. Okay, so our test statistic, Z, 2.99. P-value, 0.0028, yeah. Okay, and then we want to compare our p-value to our significance level. What's our significance? Yeah. I'm going to just add some zeros on here so I can compare it easier. So what do you see about that? This one?
No, the significance.
Yeah. Right, significance is greater. So p-value is less than. So that means what? Reject the null. And the null said that it equals half. So is he right or wrong in saying that it equaled half? We're rejecting that null. We're saying this is not true. There's enough evidence to suggest this is not true. We're going to reject it. Yeah, so he's wrong. So the results suggest that the politician is wrong in claiming that the responses are random guesses equivalent to a coin toss. All right, that is it for 18.